So coming up, we have a quiz on everything we've looked at so far with probability. So we're going to take a second to review everything so that you get it all in one spot, especially since we just came back from a break. So to start with, we started with basic probability. So how do you find probability? Well, remember you have to write it as a fraction, and our fraction is always going to be what you want. Too big. What you want on top, and the total number of outcomes on the bottom. Right? So for the first example, a letter is chosen randomly from the word probability. The probability that the letter chosen is B is going to be. And if we count the letters, we end up with 11 total letters. So that 11 is going to be on the bottom. Oh, now it's too skinny. Let's try this one. Perfect. Right, so the 11 goes on the bottom, and then I'm looking for how many B's there are. So I see 2 possible B's. So we have 2 out of 11, which can't be simplified. So I'm going to leave it. For the second one, a hat contains 3 blue and 5 black tickets. If one ticket is chosen at random from the hat, the probability that it is blue is, so again, total goes on the bottom, so I have 8 total tickets, and I want the probability of it being blue. So there are 3 blue out of the 8 total, which can't be simplified. Then we looked at Venn diagrams, right? So for this one, we're going to create a Venn diagram and then answer questions on it. So for this, we have 30 total students, 12 study French, 15 study German, and 5 study both French and German. So I have 5 study both. That means I'm going to have 2 circles. So I'm going to draw some pretty terrible circles here. I'm going to have one for French and one for German. I'm going to make my big box around it. Alright, at the top of my box, I'm going to put the total number of students, which is 30. Alright, that goes on the outside. Then I have 12 that study French. That means my entire French circle is 12, so I can't plug anything in yet. I have to be able to put French only right now. 15 study German, same thing. Whole circle is 15, can't put anything in yet. And then 5 study both French and German. So that 5 is what I can put in the middle. If you have the option, always start from the middle and work your way out. So now that I have 5 in the middle, I can go back to the 12 that study French. My whole circle is 12. 12 minus 5 is 7, so I have 7 that are French only. 15 for the whole German circle. 15 minus 5 gives us 10. And then I have to count to see what goes on the outside. So to figure out the neither, I'm going to add everything up and subtract it from my total of 30. So 7 plus 5 is 12. 12 plus 10 is 22. And then 30 minus 22 gives us 8 on the outside. Right, then I want to answer these questions. So I want to know how many students do not study French. So not French is going to be everything on the outside of the French circle. So that's the German only and the neither. So that's 10 plus 8, which is going to give us 18. Not German is everything on the outside of the German circle. So that's the 7 and 8, which is 15. Get rid of that. Right? French or German, but not both. Okay, so French or German, right, is going to be everything in my French circle or in the German circle. So we're not being very picky, but then we said not both. So that means we're taking out the middle part. So that's going to leave us with the 7 and the 10. So we get 17. Right? German, but not French. Okay, so that's all the German circle, but then we take out the French, so that's German only. So that gives us 10. At least one language. So that means that it's French or German or both. So that's everything on the inside of my circles. So that's 7 plus 5 plus 10, which gives us 22. French or German or both. So that means anything inside, as long as you're in at least one, which we just did with the 7, 5, and 10, which is 22. French but not German, so that's the French circle, and then we take out the German, so that leaves us with 7. Do not study a language, that's the outside, neither one of those, which is 8. And then study at most one language. So that means that they have to at least be in the circles, right? But then it can't be both, because these 5 in the middle study 2 languages, so they want only one. Right, so that's going to be the 7 and the 10. right? But then it says at most one language, right? So that means it could be no languages. So it could be the 0, which is also going to include the 8. So 7, 10, and 8 is going to give us 25. All right. Then we started looking at independent versus dependent. Okay, so to start with, you have to figure out if it's independent or dependent. And remember, dependent depends on what happens first, right? Independent, you start fresh every time. So independent's going to be with replacement. And then dependent is without replacement. So dependent means that I'm going to take that card or marble or whatever and leave it out. So it's going to change the probability for the second event. So for the first one, you flip a coin and then roll a fair 6-sided die. The coin lands heads up and the die shows an even number. So I'm flipping a coin and rolling a die. They have nothing to do with each other, so these are going to be independent. So then I just multiply my probabilities. So the probability that I get a heads up is 1 out of 2 times the probability that I get an even number, where my evens are 2, 4, and 6, so that's 3 out of 6, which gives me 3 out of 12. And that simplifies to 1/4. For the second one, a basket contains 5 apples and 7 peaches. You randomly select one piece of fruit and you eat it. Then you randomly select another piece of fruit. The first piece of fruit is an apple and the second is a peach. Alright, so if I'm eating it, that means it's not going back in. So this is without replacement, so that makes it dependent. Right, so now I'm going to find the probability of the first one, and then I'm going to change the second one, given that the first one's already happened. So the first you want to know the probability of getting an apple. Well, I have 5 apples out of the 12 total pieces of fruit, right? Then I have peaches. Just because I ate an apple doesn't affect how many peaches there are. There's still 7 peaches left, but I don't have 12 pieces of fruit anymore. I ate an apple, so that means there's only 11 left, right? So 5 times 7 gives us 35. 12 times 11 gives us 132. And that can't be simplified, so we're going to leave it as 35 over 132. Then we also have questions that are going to ask us about determining if something is independent just based on given the probability. So we don't know anything about the context, we just know the probabilities. Well, remember, if 2 events are independent, the probability of A and B is equal to the probability of A times the probability of B. So to see if they're independent, I'm just going to plug in our formula. So A and B is 2 out of 25 in this case. Probability of A is 2 out of 5. And the probability of B is 1 out of 5. Right? Well, 2 over 5 times 1 over 5 is 2 out of 25. So that one is true. So yes, these events must be independent. For the second one, I've got 1 out of 25 has to equal 2 out of 5 times 1 out of 4. Well, 2/5 times 1/4 becomes 2 out of 20, which is not 1 out of 25. That simplifies to 1 out of 10, not the same. So that means that these events are not independent because it doesn't fit in our formula. Okay, so we have basic probability, Venn diagrams, and independent versus dependent events on your upcoming quiz.